Hello students, this is my Matter in Our Surrounding Part 2. Please refer my Part 1 video. There I covered physical nature of matter, characteristics of particles of matter, diffusion and states of matter. Now we will get into the topic change of state of matter. We can say pressure and temperature are the two criteria which will determine the states of substance. We all know from our observation that water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. The phenomenon of change from one state of matter to another and then back to the original state is called the interconversion of states of matter. Now we see the effect of change of temperature with the help of activity. For that, we should take 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice. Now start heat our beaker on a low flame. Note the temperature when the ice starts melting. We should record the temperature when all ice has converted into water. Now again you have to record our observation for this conversion of solid to liquid state. Now put a glass rod in the beaker and heat while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. We have to again record our observation for the conversion of water in the liquid state to the gaseous state. What we observed from our activity: on increasing the temperature of solid, the kinetic energy of the particles increases, which overcomes the force of attraction between the particles, thereby solid melts and it is converted into a liquid. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called melting point. The melting point of ice is 273.16 Kelvin. The process of melting, that is, change of solid state into liquid state, is also known as fusion. And the process of change of liquid state into gaseous state is known as vaporization. When a solid melts, its temperature remains the same. So, where does the heat energy go? You must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached till all the ice melts. The heat gets used up in the changing the state by overcoming the force of attraction between the particles. The hidden heat which breaks the force of attraction between the molecules is known as latent heat. One of the important terms in this unit, latent heat. And the next term is latent heat of fusion. What is it? The heat energy required to convert 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. The next term is boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is called its boiling point. Boiling is a bulk phenomena. Particles from the bulk of the liquid gain energy to change into gaseous state. That means from liquid state to gaseous state. For example, boiling point of water is 100 degrees Celsius. If you convert it into a Kelvin state, you have to add 273.16. So 100 degrees Celsius is equal to 273 plus 100 equal to 373 Kelvin. As I told you, Vaporization is the process of change of liquid state into gaseous state. And I explained you already what is latent heat. Yes, it is a hidden heat used by the substance to break the force of attraction between the particles. And we'll see the latent heat of vaporization. What is it? The heat energy required to convert 1 kilogram of liquid into gas at atmospheric pressure at its boiling point. It is important. As its boiling point is known as the latent heat of vaporization. The process in which a gas on cooling turns into a liquid at a specific temperature is called condensation or liquefaction. See, this is the reverse process of vaporization. Okay. Formation of clouds is due to the condensation of water vapor from the Earth's surface. Right. And the last term is called sublimation. The change of state of substance directly from a solid to gas without changing into the liquid state is called sublimation. And vice versa also. That is, from gas to solid is also called sublimation. The temperature at which the state of a substance changes from a liquid to a solid is called freezing point of that substance. Here I have given interconversion of the states of matter with the help of diagram. I'll start up with solid. The process of conversion of solid to liquid is called fusion. And the temperature at which solid turns into a liquid is called melting point. And the reverse process is the process of conversion of liquid state into solid state. So the name of the process is called solidification. And the temperature at which liquid turns into a solid is called freezing point. And the next is conversion of liquid state into gaseous state. The process is called vaporization, and the temperature at which liquid turns into gas is called boiling point. And the reverse process is called condensation, where the gas is converted into a liquid. And the next is conversion of solid into a gas. The process name is called sublimation. And the reverse is also called sublimation. That is, the conversion of gas into a solid is called sublimation. As I told you before, pressure and the temperature are the two parameters which will determine the state of substance. We'll see the effect of change of pressure. We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? Do you think that increasing or decreasing the pressure can change the state of matter? Yes. Once you increase the pressure, the gases can be liquefied. When a high pressure is applied to a gas, it gets compressed, and if the temperature is lowered, the gas is liquefied. We'll see one example, that is solid CO2. It is getting converted directly to a gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Okay, here we will see some factors which will affect the rate of evaporation. The first factor is surface area. The rate of evaporation increases on increasing the surface area of the liquid. That is, both are directly proportional, right? Once the surface area increases, you will get increased evaporation. And the second parameter is the rate of evaporation increases with an increase in temperature. Both are directly proportional. Once temperature increases, evaporation will also increase. And the third is humidity. Decrease in the humidity increases the rate of evaporation, right? The fourth parameter is speed, wind speed. That is, an increase in the wind speed increases the rate of evaporation. See, these are all the four factors affecting the rate of evaporation, right? So, thus we can say that pressure and the temperature determine the state of the substance, whether it will be solid, liquid or gas. So students, in this video, I have covered change of state of matter. I will cover the remaining topics in my next video. Thank you.